Hey, let's talk about binary and primitive types. So, we've talked about binary in the past, and we know that we can take a combination of zeros and ones, and based on their placement, so the position that they're located at, assign values to them. So, just like we might say that this is the number 752, because 7 is in the hundredths place and 5 is in the tens place, 2 is in the ones place, so 752. We know that each one of these positions in binary has a value. This being the ones place, the twos place, 4, 8, 16, 32, 64, 128. So there's 1 byte, and this number would be 1, 8, 1, 2, and 1, 1, so the number 11. Now, when we get into actually writing programs and storing information like words and numbers and things like that, we know that binary is storing it all at the base, but how do we distinguish between, say, binary representing a letter and binary representing a number? So we're going to step away from binary for a moment and talk about two really simple primitive types in the Java language. One is an int, and another is a char. So int stands for integer, and char stands for character. So letters. These are used. Chars are meant to hold single letters or single symbols, and ints are used to store signed integers. So -20, 38, and then up to a max value down to a min value. So let's for a second try and figure, well, how would we actually represent a character on a computer screen? We'd say, well, maybe the letter A I would type in, but the computer doesn't store the letter A, it stores binary. So how do we get from A down to binary? Well, what we use is one intermediary step called the Unicode table, or often the ASCII table. So the ASCII table assigns certain numbers to all the symbols that we might want to represent. So, for example, A is a number 65 in ASCII, which if we went down to binary would be a 0, 1, 0, 0, 0, 0, 0, 1. So we get that number, or that binary, which turns into a 65, which we then translate into an A. But the problem is, if ints store numbers, I could also store the integer 65, which would be the binary 0, 1, 0, 0, 0, 0, 0, 1. So if I can have two sets of binary that get me to the same value, how does the computer know whether I'm dealing with the capital letter A or the number 65? All right, so this is when identifying types comes into play. And for primitive types, we identify a few simple things that we work with. So numbers, letters, true or false. That's really it. So let's use int and char as an example in a computer program. Suppose I wanted to store a value, x, which is equal to 65. All right, and then I also wanted to store a letter, let, which is equal to the capital letter A. Well, right now, both of these assignment statements are going to assign the exact same binary code to a position in memory. So I'll have some block somewhere in memory that I label X, and in it I'm going to get 0, 1, 0, 0, 0, 0, 0, 1. I'm going to have some position in memory labeled let. That gets the binary 0, 1, 0, 0, 0, 0, 0, 1. So how is my program to know that one is meant to be the letter A and the other is meant to be the number 65? We do that by identifying. So this is an assignment statement. It's assigning a value to a variable. But what I have to do in the Java language, not all languages are like this, what I have to do first is make sure that I declare what X is. Now I can either do this on this line or on a line above it. So for X, I'll do it in this line. I'll say I have an int called X, and the value should be 65. And then down here, I'm going to say I have a char named let, which equals A, the letter A. So what then happens is, in the compilation, I'll have a little table, or the computer will have a little table that says, oh yeah, X, that's supposed to be a number. That's an int. So when I pull this binary in and work with it, remember, treat it like a number. And let, oh, that's a char. So when I pull that binary in, make sure I treat it like a letter. So that's how I get that distinction. So we have two parts: the declaration of a variable, and then the initialization, where I give it its first value. And like I just mentioned, you don't need to do these on the same line. So I could say I have an int called y. I've now declared y, so that'll give me a place in memory called y. That gets a little block, but there's nothing in it, although actually it would just be all zeros right now. And then later on, somewhere later in my program, I can make the assignment statement, y equals 20. Right. Now, there's also a cool feature that you can do called casting, which says, hey, even though I know that this is a character, even though I know it's supposed to be a letter, treat it like a number, because I know I can translate it into a number pretty easily. And there's a whole other video on casting that I recommend you look into to make sense of that. So I hope this clarified a little bit about how we actually take binary and then turn it into things that we can distinguish in an actual computer program. At least with really simple primitive types like ints and chars. All right, bye now.